Hello everyone, this is Aisha Parika. I'm a student of Sri Venkateshwara College of Engineering. Today's topic is deadlock, which is a concept in the operating system. Deadlock in operating systems. Deadlock is a critical issue in operating system where multiple processes are blocked, preventing them from progressing. This occurs when each process is waiting for a resource held by another process in a circular dependency. What exactly is deadlock? Deadlock arises when two or more processes are stuck in a waiting state, each holding a resource that another process needs. This creates a circular dependency where no process can proceed. Example is let us consider two processes. Process A holds resource X and needs resource Y, which is held by process B. Process B holds resource Y and needs resource X, which has been held by A. Consequences of process are such situations are deadlock can lead to system performance degradation, resource wastage, and potential data loss. Necessary conditions for deadlock. When let us see when all deadlock occurs. Deadlock occurs when four necessary conditions are met. These conditions are crucial for understanding how deadlock arises and how to prevent or resolve it. Mutual exclusion. A resource can only be allocated to one process at a time. Hold and wait. A process holds at least one resource and is waiting for another resource held by another process. Third one is no preemption. A resource can only be released voluntarily by the process holding it. Circular wait. A circular chain of process exists where each process is waiting for a resource held by the next process in a chain. Resource allocation graph. Resource allocation graph is a visual representation of resource allocation and dependencies among processes. It helps understand deadlock scenarios and provide insights for detection and prevention. Nodes. Nodes in the resource allocation graph represent process and resources. Edges. Edges depicts the relationship between the process and the resource representing allocation and request. Deadlock. Cycles in the resource allocation graph indicate a deadlock condition where processes are waiting for each other's resources. Deadlock detection algorithms. Deadlock detection algorithms are used to determine if a deadlock situation exists in the system. They analyze the current resource allocation and process states to identify any cycles indicating a deadlock. There are three steps in deadlock detection algorithms. Resource allocation graph. One approach is to construct and analyze resource allocation graph. Second one is wait for graph. Another method involves building a wait for graph where nodes represent process and edges indicating the wait for relationship. Third one is detection algorithm. Both methods aim to identify cycles in the graph indicating a deadlock condition. Deadlock avoidance strategies. Deadlock avoidance strategies aims to prevent deadlocks by dynamically allocating resources to process, ensuring that a safe state is maintained. There are two strategies which can be applied. First one is resource ordering. Process request resources in a predefined order, preventing circular dependencies. Second one is Banker's algorithm can be used to avoid deadlock. Banker's algorithm is a resource allocation algorithm that analyzes the available resources and process requests to ensure a safe state. Let us see what is Banker's algorithm. The Banker's algorithm is a resource allocation strategy that prevents deadlocks by ensuring that a safe state is maintained throughout the system. It requires a prior knowledge of the maximum resource needs of each process. State analysis. The algorithm analyzes the current state of resource allocation and process requests. Second one is safety check. It verifies that there exists a safe sequence of resource allocation, ensuring that all process can complete without deadlock. Third one is resource allocation. Only if a safe sequence is found, the algorithm allows resource allocation to a process. Deadlock prevention. Deadlock prevention strategies aim to eliminate one or more of necessary conditions for deadlock to occur, preventing deadlock situations from arising. First one is mutual expulsion. By allowing shared access to resources when possible, this condition can be avoided. Hold and wait, requiring process to request all resources before starting execution eliminates this condition. No preemption. Allowing preemption of resource from process that are holding them but are not using them, that can prevent deadlock. Fourth one is circular wait. Imposing a total ordering on resource types can break the circular wait condition. Deadlock recovery. Deadlock recovery strategies involves breaking the deadlock condition after it has occurred. This typically involves freeing up resource or terminating process to allow the system to resume normal operation. First one is process termination. One approach is to terminate process involved in the deadlock, freeing up resource. Second one is resource preemption. Another option is to preempt resource from process that are holding them, reallocating them to process that are waiting. Conclusion and key takeaways. Deadlock is a significant challenge in operating systems that require careful consideration. By understanding the necessary conditions, detecting methods, avoidance strategies, and recovery techniques, developers can minimize the risk of deadlock and ensure robust and efficient system operations. So, I hope you guys understood what is deadlock and what are the necessities and how we can avoid deadlock. If you guys like the video, please like, share, and subscribe the video.